Hey friends, welcome to this lesson, and we're going to talk about something known as the antiderivative. Okay, what does that mean? We've been working with derivatives for this entire course, and now all of a sudden we've got this word anti. Well, anti means kind of going the other way, right? Like if I said anti-clockwise, it means I'm going the other way on the clock. I'm undoing it. So the antiderivative, friends, is the inverse of us taking a derivative. So what we're doing here is we're kind of closing our loop. Like mathematics is a closed subject, meaning that if I can go one way from a function by taking the derivative, what we want to be able to do is to take the antiderivative to get back to where we began. Okay, so this is going to take a little bit because your brain has been growing really fast to figure out what derivatives are. And now all of a sudden we're going to tell our brains to go backwards. So it's going to be a little bit of a struggle for your brain to say, oh, I've been doing this for so long, now I got to put it in reverse. So our goal here is, how do we undo taking a derivative? So where we'll begin is, let's just start thinking about taking the derivative here, okay, of something easy. So the derivative of this first one here, f prime at x, would be 2x. And the derivative of the second one here would be 5x to the power 4. Okay, so we know how to take the derivative, no problem. How do we go the other way around? Well, what we're really doing here, what we're trying, is to undo the power law. So to take the derivative, what we said was, okay, well, we're going to multiply by the power and then reduce the power by 1. Multiply by the power, reduce the power by 1. Okay, well, if we want to undo that, we're going to do that in the opposite order. So what we're going to do then, instead of subtracting 1 from the exponent, we're going to add 1 to the exponent. So 1 plus 1 is 2. 4 plus 1 is 5, right? So add 1 to the exponent. And then now, instead of multiplying by the coefficient, we're going to divide now. We're now going to divide by that new power. And that's going to get us back to where we were. Okay, like I said, it's going to take you a couple of minutes to wrap your head around this. So to undo this, to take the antiderivative, and this notation for antiderivative we're going to use is capital F of x. So to find the antiderivative, what we're going to do to undo the power law, we're going to add 1 to our exponent, and then we will divide by this exponent. Okay, and that's us undoing the power law. We will learn as we go through how to undo things like the chain law and the product law and the quotient law and all that good stuff. Okay, but today we're learning how to undo the power law, the inverse of the power law, essentially. Okay, let's try this again. So let's take the antiderivative of f at x is equal to 10 over 9, x to the power 9. And the first thing I'm going to do is I'm going to rewrite this. Now I'm going to take the antiderivative, so capital F at x. So I'm going to add 1 to the exponent and divide by it. And I'm going to simplify. Negative 5 over 4, x to the negative 8. Okay, now the nice thing is here, I'm going to check my work. You can tell me if you've done every one of these questions correctly. Here's how I check my work. Because the derivative of the antiderivative better equal f at x. If it didn't, I did screw up. So I'm going to take the derivative of the antiderivative. They should undo each other. So negative 5/4 times negative 8 and subtract 1 from the exponent. And that's going to be positive 10 x to the negative 9. And that's exactly where we began. Nice. So we did it correctly. Okay, what I want you to do is I want you to hit pause on the video and I want you to try the next question here. Try to take the antiderivative of this function. I'll see you in a minute. All right, friends, let's see how you did. So antiderivative, capital F at x, add 1 to the exponent, divide by it. add 1 to the exponent, divide by. Add 1 to the exponent. Well, what's the exponent here? Well, really, it's x to the power 0 because it's a constant term, right? So now it's x to the power 1. And simplify. 2x cubed minus 4x squared plus 3x. How'd you do? Okay, hopefully you nailed that one. All right, now that you're starting to wrap your head around how to undo the power law, I'm going to add in one more little thing. When we check our work by taking the derivative of the antiderivative, and we're kind of making sure that we end up with what we began with, we need to add in just one little thing here. What's the derivative of a constant? What's the derivative of a constant? Well, the derivative of a constant is 0. So if I took the derivative and there was a constant back here, would I have been able to tell when I took the derivative that that was there or that wasn't there? Because really what I'd end up with back here is a 0, right? Because the derivative of a constant is 0. So friends, what I'm trying to say here is to make sure that we've completely closed our loop. When we take an antiderivative, we're always going to add a constant at the end. Now, we don't know what that constant is. Is that constant 1? Is it constant 99? Is it a billion? I don't know. So what we're going to do is we're going to put in this plus c here. This is known as our constant of integration. It's what we're going to put in when we take the antiderivative. Because again, the derivative of that constant is 0. And look at what's back here, plus 0. Okay, so just make sure whenever you're taking an antiderivative, you're going to add in this constant of integration just to make sure that we've got all of our bases closed. Later on in another lesson, we'll figure out how do we figure out what that constant was. All right. Okay, let's try a couple more, friends. So let's take the derivative of this guy. So the first thing I'm going to do is I'm going to rewrite this just like I would have when I was first learning derivatives. I'd make my life easy. So all I'm doing is dividing everything by x. And here we go. Okay, so now I take the antiderivative. So I add 1 to the exponent and divide by it. Add 1 to the exponent and divide by it. Well, dividing by a half is 2 over 1. Now, what about this one here? Like if I had written this as this, if I add 1 to that exponent and divide by it, I've got myself a big problem because I'm dividing by 0. Is math broken? Well, no, math's not broken quite yet. What I'm going to do is I'm just going to rewrite that like that. What I want you to say is, what function would I take the derivative of to get 1 over x? The derivative of what function would give me 1 over x? Well, the derivative of the natural log of x gave us 1 over x, didn't it? So guess what? The antiderivative of 1 over x is natural log x. But I need to just be a little careful here because for 1 over x, the values of x that are permissible there are all values except for 0. But a natural log can only have non-negative values plugged in. So I'm going to put absolute value bars there to make sure that I'm not getting a negative value in there and not a 0. Okay, so I should have said the values of x can only be positive, right? But now, because here we could have had negatives, to account for that idea that we could have negatives, we put those absolute value bars there. Okay, so you just learned something else new. The antiderivative of 1 over x is natural log x. All right, and then don't forget your constant of integration. And you could check your work by taking the derivative and you would end up with what you began with. Pretty cool. Okay, so now, friends, let's take a look at another one here. We're going to take the derivative of a trig function. So I'm saying to myself, what the heck? Okay, well, let's switch to blue here. I say to myself, okay, let's just remind myself, what's the derivative of sine x? Right? What's the derivative of sine x? Well, the derivative of sine x is cos x, right? Okay, so, my immediate inclination is to say, okay, so the antiderivative then would be 3 cos x and plus c. Okay, I go to check my work. So I take the derivative of the antiderivative. Well, the derivative, well, wait a minute, what's the derivative of cosine? Derivative of cosine isn't sine, it's negative sine. Ah, that's not what I began with. I began with positive 3. So how do we fix this, friends? We fix it by saying this. The antiderivative of sine is negative cosine. Now check. So if we take the derivative of the antiderivative, now we're going to get negative 3 times sine x, but the derivative of cos is negative sine, and that would give us that positive 3. Okay, so you spend all this time learning all these derivative rules. Now you've kind of got to, again, you're working backwards. So your brain's going to fight you a little bit when you're doing this, rightfully so, because you're doing something completely new, aren't you? Okay, so a couple of small things here then. So if our original function, f at x was 1 over x, the antiderivative is the natural log with the absolute value of the natural log. Okay? If our original function was sine x, what we're going to find then is the antiderivative of that will be negative cos x. And of course, if we had the original function was, what are we missing? Cos x. Well, if the original function was cos x, then, so I'm just going to write it off to the side here because I ran out of room. Bad teacher. If the original function was cos x, then the antiderivative of that would just be positive sine x. And again, if you're stuck, you always just take the derivative and work backwards and see if you end up with what you should. Okay, there's the antiderivative to undo the power law. Have fun.